Hello, everyone, and welcome to our Tag Inspector webinar series. Today we'll be talking about tag performance, some of the metrics that matter, some of the metrics that don't matter, why those things matter, how they play in, and some of the just tips for optimization. Got a few minutes until we start, so hang tight, and we'll be back in a moment. All right, looks to be right around 11 a.m. our time, so we'll go ahead and get started. I see a few people still trickling in, but the more the merrier, and we'll go ahead and let them catch up. So, as mentioned, thank you all, well, first for joining us today. Another one in our Tag Inspector educational webinar series. One common theme, I guess, has been of late tag performance, some of the different things that matter, how exactly to find different performance metrics within the Tag Inspector scan reports, and just how to use those to optimize tagging on your website. Today, want to cover, because we've been doing a number of different studies internally here at InfoTrust looking at the different metrics around performance. Want to cover really what matters, what doesn't matter, and then why those things either matter or they don't, and in what context. We talked to a lot of people around the different performance metrics that they're looking at and that they're trying to optimize for. And one, there is no traditional consensus as to what to optimize for, so we hope to be able to correct and change that. But also a lot of people looking at different metrics, some of them, not really useful and not really moving the needle when it comes to page performance, user experience, data collection, and how tags are factoring in. So, quick little housekeeping bit just about Tag Inspector and your presenters. Tag Inspector, as many of you know, is a product of InfoTrust LLC. On the InfoTrust side of things, we do web analytics, tag management, product development, with Tag Inspector being the primary software product. Over 2,000, several thousand sites analyzed and worked with on an annual basis. We do a large number of digital marketing and analytics and tag management training programs, these webinars being part of that. Offices in Cincinnati, in the US, in Dubai, and soon to be Barcelona, Spain. Presenting here today is myself, Lucas. I'm our Tag Inspector product manager and also a tag management consultant. And then I'm also joined by Tyler Blatt, who's one of our tag management and analytics engineers.
Hello, everybody.
Cool. So, quick rundown of what we're wanting to touch on today. And before I do that, if there are any questions that come up throughout, please don't hesitate. Just throw them in the questions pane. We'll be answering them, throughout the webinar, answering anything also at the end that we maybe miss or don't catch. And then, as always, if there's questions that come out of it or come out of the webinar or anything specific for your website, please feel free to email us, let us know. Happy to hop on a call, walk through any of your reports, walk through any of your data, and be able to help out in any way. So quickly to run through the agenda. First, I just want to do a quick high-level tag performance review. I want to review exactly how your site works for all the different content that's on the site, as well as the tags that are on the site, how tags play into overall site performance, page performance, user experience, and then we want to review the different metrics to take a look at and in all the different pieces and parts of the process. From there, I want to go into really digging into the performance metrics that matter. I want to pull out some of the analysis that we've done on our end, looking at the relationship and correlation between some of the different tag performance metrics and page timing events. And then we'll get into how to optimize for those particular metrics and things to keep in mind. Lastly, just want to touch on some data considerations. Performance of tags pixels goes beyond simply, is my user experience being affected, but also is the collection apparatus for a lot of the different marketing, analytics, media platforms that you're relying on for decisions around budget spend and trying to optimize your website. How are those things and the data being collected also affected by the performance of tags? So I want to touch on that a little bit and how we can optimize. At the end, as always, run through a quick summary and then answer any questions that are still outstanding. But yeah, let's get started. So to start out, just a quick review, and if you've joined a number of our webinars, you've likely seen a variation of this before, but as far as tags and performance, just site functionality, how that is working. So we have really three different aspects to how the website's working, how tags are working, how the internet is working in general. So you have your client side, which is the browser. That's what the user is actually using to build the website, make all the different requests for content, for images, as well as making those different tag requests for data being collected by those different platforms. It's all happening within the browser. It's making those requests, pulling down those files, combining and rendering everything, showing it to the user so that they can access your website. In between there, the highway or the connection on which the browser is making those requests is the internet itself. Literally a bunch of wires going all over the place, actually sending and receiving that information. And then on the other end is the servers. So your website, all the content of your website is sitting on some servers. The tags and all the different marketing platforms that are on the website are sending requests and asking for JavaScript files from their own third-party servers. So that's where all those requests go to. And then everything gets returned back to the client or the browser via your connection or your pipe in order to make everything work.
One point that I want to make, and Lucas has already kind of dived into this, but a very large problem in this space, which I have found as an engineer in this space, is finding jargon in which we can all communicate and talk about these things effectively with each other. You know, like what's a tag, what's a pixel, what's the client, what is the server, what does what do internet speeds mean, what happens if the connection drops, all of these weird questions or things. So one, being able to phrase these questions and speak in the same way comes from an understanding of what's actually happening. So for some of you, this may seem high level. You understand that there is a browser, there is an internet connection, and then it is loading resources from an array of different servers that are out there. But what we do in this presentation that we're going to walk through, just so some of you might be getting a little impatient, we started these high level concepts, and we're going to drill down to how do all of these things really work deeper and deeper, and what metrics really matter when we're thinking about the performance of our site. So at this high level, Lucas did a great job of explaining this. But as we step through this, we're going to learn how we as both engineers or as business people can talk amongst our developers or our different business departments using the same language and meaning the same thing. And if they don't understand, we want to educate people so that when we talk about these things, they mean exactly what we're saying and they don't kind of have a hidden meaning.
Perfect.
So one of the things when we look at the specific client, so and like Lucas described, what is the client? Well, we're talking about the machine on which the browser is running as well as the browser that is running on it. So you think cell phones and whether they have Chrome or the native like Safari on iOS, or if it's Internet Explorer, Chrome, or Firefox on the on a regular machine or on a PC. So whatever it is, we're talking about how the client is going to affect tag performance, and it affects it in things like on the CPU or the processor. So how much time is it taking to process all the JavaScript that you're loading in? So if each request is pulling in at a really high level, each request, so if you pull in an image, that's got to go out, and then there's bytes coming in from that image that need to be compiled into a visual thing, and then that visual thing is then rendered by the browser and shown to you. So in that process, it doesn't take a whole lot of processing power, but the more you have, the slower the page is. And if you want to think about this in a really obvious situation, go back to 1994. You're on your AOL computer, and the image is loading line by line. It used to be in the old days we could see this very visually on just one image. Machines have gotten a lot better, so now we don't see it as quite broken down like that, but the more assets we load in on a page, the harder it is on CPU. We're effectively getting that same performance hit. It's just not as obvious. So the more you stack that up, the more it becomes a problem. Another huge topic in this, and what I think is one of the most paramount, is the browser limitation, and that is the amount of concurrent hits it can send out. Let's talk, for instance, you have an e-commerce website and you're selling shoes, and there's 60 shoes that need to load in on that page. So you have 60 images. Oh, well, you cannot load all 60. If those images were coming from an outside source, they weren't included in the original download of the page. All of those things would then have to reach out to the content delivery network they're on, or CDN, and then download. For each one of those downloads, you can only have so many of them happening concurrently. So if there were 4, then you would have to do, the first 4, and then the next 4, and the next 4, all the way until you reached all 60. So the amount of the limitation that browsers have can affect how your tags, specifically we're speaking to marketing in this situation and not just images. So it'll affect the number of tags that are running on a page and how efficiently those number of tags can run on a page. And the last piece is site code, just how complicated it is. So in my example, like I said, if you had 60 shoe images and it's just really heavy images and they weren't compressed down, and you have 200 tags firing and you have a huge code base, it might take a long time for the code to load in. Then since that code's taking longer, it's going to take longer for your marketing tags to fire. It's going to take longer for everything to happen. So having a nice, clean, total page load helps with that. So.
The second part, so obviously that covers the client side, the browser, machine. The second part is your actual connection, and a few different things that factor in here, primarily just the bandwidth. So one thing that, as you're trying to optimize and determine what point to optimize to and what to work on when you're optimizing the deployment of tags on the website, we need to understand, for a typical user of our website, what is the size of the pipe? What is the speed of that connection? How much can an internet connection handle at once, again, for a typical user? If we're a website where most of our users are accessing our site using Chrome on a PC, that's going to be vastly different for what we need, the metric that we need to optimize to, versus if most of our users are accessing our website on an iOS device, accessing our site via Safari. So we need to understand the bandwidth and what that connection is able to handle.
And towards the end of this, we'll show you there's some tools or some understanding that you can use to getting an idea of what bandwidth you're going to have based off your devices, what you think what portion of your target audience is going to be, and supplementing some external use of some other things, you can really get an idea for how to structure that so that it hits the best part of your audience. So you can kind of tweak that or move it around so that we know what is the core part of our audience using and what's the best tag structure that's going to fit them. What's the second best core, and how can we alter it from the original to fit that a little bit better, and you can kind of work out what's going to hit you best overall.
The second piece here gets very literal, but distance travel. So the internet is literally a bunch of wires. So while small, location matters. If a particular media partner that you're working with and you're trying to collect user information from users on your site, and their servers are all in, say, Europe, and most of your users are sitting here in the United States, it's going to take longer you're going to have more latent tag requests. It's going to take longer for those tags to execute as opposed to something that's being served from and collecting that information to servers here in the United States. So most vendors now are going to have a cloud architecture so that they can spin up servers and have servers close to where the users are, but just something to always keep in mind. And then the final thing here, just connection speed. How quickly can our requests and responses travel? And that goes back to, again, understanding the devices, understanding the connection that your users have on the website.
So we want to talk about what goes on server side for loading in a tag. And I've got a number of slides here that are going to kind of break this down, but we need to understand what are the real performance metrics that we should be paying attention to with a tag, and what do they really mean? So I said something at the beginning of this webinar that we need to use the same terminology. Obviously I'm working as a consultant in this field. I see people use these terms wrong on a daily basis. And understanding these terms and what they really mean is how you can effectively communicate and make good changes on your website. So if you say one of these incorrectly, then a developer might be like, well, why does that matter? And then you're thinking it's this paramount term. So you're obviously that miscommunication become a big problem. So we're kind of going to break down what each of these mean, but on a high level, what are all of these? So latency is essentially how long until the server can tell us that it's awake and where it is. So I'll break down what the whole process of that is, but essentially when you go to load in a tag, you have to find that server that tag lives on. So I'll use Google Analytics for an example, and if you need to load in Analytics.js to be able to send your Google Analytics hits, you need to know where does Analytics.js live? What server is that on? You have to determine the IP for that, and then you have to say, will it give me the text file back that is in the format of JavaScript that I'm going to be able to run those things. So what latency really is the time to find out if it's open. And it's not the download of that tag. It's not the contents or what that URL is. It's just how long until I can communicate to this server to know that I can start the download. Then you have the processing time. So the processing time is once I've downloaded this tag, how big is the JavaScript that's coming in, and how long is it going to take to compile all of this? There might be some piggybacking. So you might pull a JavaScript tag in that has 8 other JavaScript tags on. How long does it take for all of these things to process? What is the amount of, I talked a little bit earlier on what CPU usage was, and we could see that line by line image getting loaded in. Well, the same way that image is slowly compiled by the processor or the GPU, the graphics processing unit, whichever it may be, the processing resources that we're using, they would go line by line, or our JavaScript does the same thing. It is, and just like it used to be slow, now it's going much faster. We're in a newer age where these things are faster, but we're also using much more JavaScript than we used to use in the past because we've kind of expanded on what the marketing world has been. So with these huge pages with 100 tags firing on them, how much processing time is getting used by all of these tags? So when we speak about tag performance, each individual tag needs to be audited on how much time it's using up, and then the location of that tag. So where on the page is this tag loading? If it's not that important, why is it loading in the header before any of the content's been loaded? If it's really important, why is it loading at the very bottom of it? So understanding how a tag performs and its importance to where it needs to be on the page, you'd be able to measure where that tag should live based off of its importance and the other metrics that we have.
So that's a high-level view at the 3 different stages to the process. So on the client side, your browser is rendering or reading the code. It's going to come across that line of JavaScript that is your tag. It's going to send a request through that connection / pipe to the server for that particular platform. The server is then processing that request and returning, an additional file, additional function, whatever it is, additional script that would be running on, again, through that connection on the way back, and then being downloaded and executed by the client. At which point, additional requests are being created, and those are being sent up to the server, and that's how data is being collected. So tags are those little JavaScript snippets that are embedded within the code that are making those requests back and forth. So that's how they play into it. Now, looking at tags specifically and some of the metrics that matter, or just general metrics around tags, and we'll get into why, which of these are more important, as well as why I guess each of these are a little bit more important. So a few things to look at when analyzing tags. So there's a difference between a synchronous loading tag and an asynchronous loading tag. And the easiest way to describe this, synchronous loading tags are things that can only happen by themselves. So with asynchronous loading tags, they can happen in parallel with something else. So they don't have to take up all the different resources. Synchronous loading tags, as soon as it gets executed, it's going to stop and block anything else on your web page from happening until that whole file is downloaded and everything is run by that particular tag. So when analyzing tags, we need to be able to identify, are any of the tags that are running on our website synchronous? Should they be? Do they have to be? And if not, we want to change those to asynchronous loading tags. And if they are, it highlights really the importance of optimizing performance from a latency standpoint, from an execution standpoint, from a deployment, where exactly those tags are. Because a synchronous loading tag on your website is going to be the number one potential cause for a user experience problem.
That's 100% correct. I'll break down what a chart of things working synchronously looks like a little bit later, or asynchronously, I mean, and then I'll point out what a synchronous tag can do to that chart, which is pretty much catastrophic. And there are a very, very limited number of tags in the space that are synchronous. And every time, as a business holder, when someone says, I have a synchronous tab, you should very scrupulously ask why. And unless they can give you a very, very good reason and that thing has a high business value, you should just say, well, until you get async, we can't put this tag on our site, because it's essentially always going to be a massive performance hit. We'll get in a little bit later as to why, but it's a very bad thing for it to be synchronous. And again, using these words will help you communicate better with your team. So understanding what synchronous versus asynchronous means, literally that the tag can only load and execute by itself, as opposed to load and execute in conjunction with other tags, will help you be a better communicator.
So the next thing with tags here that we would look at is the request size and then also the request volume. So the size of requests is going to be the size of the file that needs to be downloaded and then run on within or by the browser. So like I mentioned here, and as is noted, there's bandwidth implications. So going back to what I was talking about earlier about how we have to be cognizant of the browser type, browser versions, and connections that most of our users have. So even in a vacuum, with everything within the browsers happening perfectly, the user's running nothing else on their machine, no additional tabs open in Chrome, which I think we all know never happens. But if all conditions are perfect, there's still going to be a limitation for the speed in which everything on your web page can be downloaded and processed based upon the bandwidth, because things need to be sent, things need to be received, and so we need to keep that in mind. Tags are adding to that overall page size, especially when we get into issues of piggybacking and or daisy chaining, where you have one JavaScript file loading in many, many more. So we need to look at the size of requests. We need to look at the volume, how many requests are being sent by each individual platform, as well as overall on a page. And we need to be extremely cognizant of additional JavaScript files being loaded in, because all that is resulting in is additional size, additional requests.
Yeah, I think Lucas pretty much covered it here. We'll get into, there's another slide later that'll talk. It shows what an example constraint on both bandwidth and the number of things being pulled in based off of that bandwidth. So for example, if you have 4 megabits down and 4 tags loading at the same time, you have a megabit per tag per second to load, and how that's split up amongst the tags and how that affects total tag loading on the page, and how a large tag or a fast tag can affect how those load in. So we'll get a little bit into that later, but generally this is a good high-level understanding.
Next thing here is just the nature of requests. There's different types, different functions, different processing that's required. Something that is loading in a full JavaScript file is completely different from something that's just a 1x1 image pixel, in terms of how much processing is required, the size of the file, what that download looks like, size of that request. as well as even latency implications there. So kind of everything is factored in when it comes to the nature of requests. And then the final piece here is just the latency of vendor servers, which that is what's going to contribute to the latency of tags. As we'll get into, latency becomes a little bit more important as we need to understand and have expectations for how and when tags are going to be loading, but doesn't factor into overall page performance really at all. So that's the high-level review of just the tag performance metrics, how exactly tags in your website is working, and what are the things that we're going to be looking at and digging into a little bit more. So now we want to dig into the performance metrics that actually matter. We want to go through some of the analysis that we've done so you can see some of the actual correlation and the numbers around those, and we'll get into why these things really matter. And as we start to work through that, I think it'll make a lot more sense and make it a little bit more logical just as we work through what to optimize.
Okay, so one of the ones that I think is a high priority target for people to look at with tags, which we'll get to a little spoiler alert later, doesn't have a huge impact on page performance, but people see this number, they see it being high, and they freak out. And it shouldn't be high, but let's talk about what it is first. So it's tag latency. And what really is tag latency? So I talked about this a little bit earlier, but it's the time to establish the connection with a third-party server. That's a really good, succinct definition. So what it is if you think about the server being, your buddy's cell phone, and you need to call him late at night, and you send out a text message that says, "Hey, are you awake? I need to send a phone call." And then he says, "Yeah, I'm awake. Go ahead and call." The call would be the download of the tag, but what you did was you just found out that you can start that download. You made sure that service or that server is awake, listening, and ready to start the process. There does exist a time. I know we've all seen 404 errors on tags or 500 response or these different error responses where the server wasn't able to properly identify what you were trying to receive or whether it was awake or there was just no response and it timed out. You've seen server timeouts before. Essentially, latency is the amount of time until we know we communicate with that server and there isn't going to be an error downloading that tag. That's it in kind of the short span. This is not the total. I put it in bold here, and I can't be more emphasize this enough. I can't emphasize it even a little bit enough. This is not the total download. People see this number and think high latencies across their site are the amount of total tags loading on the page. It's the amount of time spent to contact all these servers, not the total download of the tag. So in my Google Analytics JS example, the Analytics JS file, that huge text JavaScript download that's going to happen and that JavaScript's eventually going to run on the page, that would be the download, pulling that text down. But getting to the server to understand how long it took would be the latency. We've got some slides here to go through a little bit more on breaking down all of the pieces to the latency. So I'm sure everybody's heard the word DNS before, one way or another. Somebody was selling you an internet package, or you looked into what it really means, or they just say our DNS servers are down, and you don't understand. But for those of you that do DNS, bear with me. Do know DNS, bear with me. I'm going to explain a little bit. What it stands for is Dynamic Name Server, and what it really is it's like an address. So if you think of your house spatially and where you wanted to get mail sent to, it's kind of hard to remember exactly where that is. So what did we do? We added names to our street names. We just didn't want to have numbers all over the place to remember, like, I live at 133789247. We gave it roads. So your road might be like, Jefferson Lane and a number. So as humans, we come up with systems that we can assign words to very cryptic number-like systems. That's exactly what DNS is. A dynamic name server is, I don't remember, I think Google's changed it, but Google used to be, their IP address was 8.8.8. 8. So it was 4 8s with 3 dots in the middle. I don't know if I said that right, but essentially when you typed in www.google.com, you were really typing in 8.8.8.8. But we needed DNS servers, dynamic name servers, to tell us where those words pointed to what IP address. So it's basically taking the words or the URL that you're passing in and determining what IP address that's in. So this is sometimes cached on the machine level, so sometimes your computer will determine where that is. So if you type in google.com, your computer's probably got the IP address cached and it doesn't even need to ask the router. Sometimes it's cached in your personal router or your workplace router. Sometimes it is cached at your ISP or internet service provider. And then sometimes we got to go all the way out to dynamic name servers and find out. If you're searching for an obscure website, it might need to go out. This is where you see some of those long latencies for tags that people don't use a lot. So if you're using a really obscure tag that they might not have visited another website or no one else from that ISP had visited, it wouldn't be cached. But essentially, all DNS start to DNS end is the time to look up the IP address based off of the URL that you have. That's the most succinct way that I can describe that. So then you have your connection start and your connection end, which is basically how long is it taking me to establish a connection to this server. So you're saying, okay, I've got the IP address. I want to talk to this server now. I need to know, what's going on here. So this would be the typing in of the number in your phone conversation. This is sending out a ping to the server and saying like, okay, are you awake? And essentially, it's actually not the sending out the ping. It's just seeing if there's any kind of response there. And then from your send start to send end would be you're essentially that's the entire process. But the connection start to connection end is sending the text message. Sorry, I said that a little bit confusingly, so I'm going to go back. The DNS to DNS end is looking up the name, but the connection start to connection end is saying, hey, are you awake? Yes, I'm awake. Go ahead and send the call. That entire process would be send start to send end the whole time, and that is your latency. So that sent start to sent end is the total latency in this. This is, for those of you who didn't know, we didn't point this out before we even started on this. This is from a tag inspector report, pulling out what the different tags are and what their entire latency is based off if they had long DNS lookups, if they had long pings to the server to find out if they were awake, and then the tag download is in a different place. But that's essentially latency in a nutshell, is looking up the DNS and then checking to see if the server's even awake. So here's an example too of why it can take so long. So this doesn't show the whole thing, but this was from our office, which is in Cincinnati, Ohio. You can see the line going right through Ohio. These are only the 7th, I think the 8's hidden behind there, 9th and 10th. Hits, so we don't even see us pinging from the office. But when I typed in google.com, how many jumps it took before I could actually connect to that server. And while it's not really intuitive, the reason it can take so long sometimes, Lucas said the internet's a bunch of wires, but it's wires set up with the efficiency that sometimes you see with the U.S. Post Office, that they have to send it to a hub in the opposite direction because that's where the plane's going to the other direction. So maybe New York was the closest to Cincinnati for a big hub to do a cross-country connection. For some reason, it had to come back to Kansas to get something that was lost along the way. I don't know what was picked up or why it took that particular route, but each time you make a ping, these crazy jumps are happening. We're jumping all the way across the country sometimes. We're jumping overseas sometimes. So you can see these longer latencies. But once you find out where that connection is, you establish it. That connection is also suspect to a download speed for how fast that server will serve it up. That doesn't necessarily mean it'll be faster and slower, but latency is essentially how long it takes to make all these hops to figure out where we're going, and we know the path then on the response to begin the download stream.
That's just basically, here we're just basically summarizing what Tyler broke down. So bolded there at the bottom, our latency is the time from the DNS lookup to the time the server told us it was awake. So again, just to emphasize the point again, latency is not how long it's taking to download or actually run that particular file. It's just the time to basically get the file, or begin getting the file, asking for it, and begin receiving it.
It's establishing the connection to the file.
So when it comes to latency, why did we really dive into that? I want people to understand when it comes to tag latency, it's different from, and it matters in a different context than page latency. I would say probably 80% of the people that I speak with that are trying to optimize their websites and their tagging architecture, and when you ask them why, and they say because we think that tags are having an effect on the performance of our website, the next question I always ask is, well, what are you optimizing for? What metrics are you looking at? What are you evaluating prior to deploying a tag on the website? And 8 times out of 10, they're saying latency. You might have a particular limit, say 200 milliseconds or 500 milliseconds, and we're evaluating tags and making sure that they're within that particular limit. So being the most popular thing that we come across, what we did looking at data that we collected over several thousand scans of several thousand websites, did some modeling looking at average latency, median tag latency, and comparing that and seeing the correlation between those latency figures and page timing events. And Tyler, if you want to quickly touch on just the page timing events, what they represent.
And here, so essentially,
DOM
you have DOM interactive, DOM content loaded, DOM complete. What does DOM stand for? DOM is your document object model. For people that have no clue what that means, it's essentially your HTML that is loading in. It's your initial page load. This isn't the things that are loading in after the fact. This is just your initial page load, what you're pulling in for what would be your page outside of outside tags. So DOM interactive this is JavaScript the first time it can be running. This is as soon as you can start doing things on the page. HTML in its earliest, the page might not be all the way loaded at the bottom, but at the top you're seeing things and you can interact with the page. It's the very first thing that you're seeing. So then you have all these image files coming from the servers, all these other things that are slowly loading in. It's easier to tell visually on slower connections. But essentially the difference between interactive and content loaded is we've gotten all of the images and the things in that need to be put on the page. We're just in the process of wrapping up the loose ends, which would be DOM complete. We are finished loading the page in. So DOM content loaded is kind of signifies we've got everything down, we just haven't finished putting everything on the page. So one more succinct pass through this. DOM interactive, very first thing, as soon as the page is loaded and you can see it, this is the first thing that happens. Then once we have all the information for the page downloaded, content loaded would fire, and then DOM complete would be a full page load. We have everything that is loading in is now finished.
So when it comes to, and just as marketers, as business professionals, a lot of times you'll see and you'll hear, especially coming into like the holiday season, which we're quickly approaching, is a lot of those different numbers for if page latency or page speed decreases by 1 second, then conversions drop by 10%, whatever that number is. And so you hear a lot about trying to improve page performance in order to give yourself a chance from a user perspective, and so they're not going to hop off and bounce and not just get fed up with the website and go buy something from a competitor just because they have a better experience. What you're optimizing for there in the context of a page load are going to be those DOM content loaded and then DOM complete numbers. DOM content loaded, typically everything is there on the page, at least the core elements of the page, your content as well as your images. So if you're an e-commerce website, DOM content loaded, people are going to be able to see the product, be able to interact with the website. And then at DOM complete is where all the product recommendations and all those other little loose ends are going to be tied up. So we're optimizing for those different page events. As we can see here, when it comes to tag latency, we have little to no correlation at all between tag latency and those different DOM page timing events. So what does that tell us? In a vacuum, at least, looking at latency as compared to, does it affect the load of our pages? Does it affect how long it's taking in the user experience of a web page? No, it's not. So the 80% and many probably on this webinar that are looking at tag latency as the be-all, end-all number for trying to optimize and reduce any sort of page performance issues as a result of tags, we're looking at the wrong metrics. So what does matter? What are some of the other things that do factor in? And thinking back to how, when we're breaking down how tags play into overall page load and how that page load works, one thing that we were really trying to emphasize was the overall size of a page, because it factors into bandwidth, it factors in on the client side, and also leaves more to go wrong when it comes to the server side as well. So one of those aspects is the tag size. Now, tag size, we're looking at the total size of the download to pull down and run that tag or run that different function. So it's not how efficiently the code runs, just how much code is in total is in the text download of the tag. And it can be 0 for tags with no downloads. But total tag size, or the size of all tags, lets us know how much stress we're putting on the page. How much additional stuff is the browser and is the user's computer having to run when it does that, and also how much needs to go through those pipes. Are things going to get jammed up based upon the connection of a user? So tag size there does factor in. So as we can see here, the two metrics that we're looking at, sum of overall tag size, that would be the sum of all tags on a page, as well as overall page size, and their correlations with our page time events. So we have that time to DOM content loaded. We're looking at around a 0.5 on the scale of correlation, 0.55 to DOM complete. So we have a moderately strong or moderately positive correlation between our tag size, sum of all the different tags that are on a web page, and our page size. So this has close to a one-to-one, or sorry, a one-to-one-half relationship. So as we work to decrease our tag size, decrease our page size, we can expect our DOM content, time to DOM content loaded, and a time to DOM complete for those to improve. And the reason for this, from a technical standpoint, I'll let Tyler expand on.
So we talked earlier, Lucas was talking about internet from a pretty high level. You understand that there's a number of tags asynchronously being pulled in, and your entire content load of what I broke down earlier. The DOM complete is what we're looking at. How long does it take for your full document object model to get built, which has nothing to do with the marketing JavaScript you're running. That's purely the visuals that are happening on the page, is what that stands for. However, tag size 100% has to do with all the marketing that we're running. It's all of these tags that we're running on a given page. So all of those are sharing an amount of a connection. Any tag that is running before DOM complete is also slowing down and splitting off connection assets that essentially could be pushed towards that DOM complete. You're looking at, like I said earlier, if you have 4 things loading in at 4 megabits per second, each one is loading in at a megabit per second. Well, the faster the connection speed, you can split those things up a little bit better, but at lower connection speeds, depending on how fast the connection speeds of your clients go, if you have a very heavy page with very heavy tag size, so your page size and tag size are splitting multiple things loading in at once, all at the same time, and what you're going to see is a slow page performance. You're going to see the DOM complete slowing down. You're going to see this moderately high correlation between tag size, and the more that tag size grows, the more the correlation is going to grow. So this is something that is definitely a place to clean up. It's definitely a place to look. The size is the total download, like we said in latency about 1,000 times. Latency is not download. The size, the total size of that tag is what the download is. That's what we're pulling in. So I think we have some slides here to talk about this a little bit more.
Yeah, this is the example, and just a quick note about tag size, piggybacking off of Tyler's point there. The overall, all the different tags that are loading on a website are contributing to the overall page size, which is contributing to how much needs to be pulled down, how much needs to be run. So one note just about page size: bandwidth is the total amount of data able to be transferred at once. So when we're talking about the splitting up of those different resources, it's not just tags that need to be loaded in. It's also the content of your website. So your product visuals, your product descriptions, your buy now button, all of that functionality needs to be loaded in. And if we have a ton of tags loading on the website, it's taking up and having to reallocate some of those resources. Now, I mentioned way earlier an example for the connection speed or your bandwidth, what your connection number is, and based upon a goal. So if our users have a 5 megabit per second connection, and we want our page to load in 3 seconds, the max page size that we can have for that to happen again in a vacuum, assuming all things are perfect with the machine, with the browser, the max page size would be 1,875 kilobytes.
Let me make a note here too. So any tag that fires before content complete or DOM complete would be rolled into that number. So these are all the tags that you're firing before DOM complete plus the entire size of the page cannot be more than that amount to get it done in that amount of seconds. There's actually a couple external limitations that could fudge this number up or down depending on what browser they're using and how quickly that could come in. But this is a pretty close estimate to what you should be targeting and a good benchmark for what you should be looking at. Um, I think a lot of people, again, get lost in the latency world or in the number of tags that are loading and don't necessarily look at this size metric, which is the big performance hit. One thing that you can do when measuring, when you find tags with performance hits too, is if I get you a list of tags, you look at what the median of your size is, of your tag size, and then you split your tags based off of that median. And what are all of the tags I have that are bigger, they're on the larger scale, and then hand those off to your business teams and have them evaluate them on their importance, rank them in order, and then look at the lower ranking ones and decide, do I really need these? How much value is there in a 3-second load as opposed to a 5-second load and these 3 to 4 tags that are really pushing us over the edge? But understanding what performance metrics you want to get at, what the size of the tags that are loading on your page are, and which ones can kind of trim the fat, so to speak, you could really improve the performance of your website very quickly with not a lot of work. Ripping tags out is easier even than ripping weeds out of your garden. I mean, it's just delete the code and it's gone forever. So with very short dev time, you can clean up some of these areas that you might not even know are big problem areas.
Now, one thing just prior to anyone panicking, when we talk about max page size, around 2,000 kilobytes, the average size of a tag in most cases, you're talking about 5 kilobytes, 10 kilobytes. If it's your full tag management system configuration, it might be 100 to 200. We're not talking about massive, massive files. What really factors in, we'll touch on it here in a second, is the volume. When you have on a lot of large e-commerce sites, you might have 50, 60 different tags firing on a page. Some of those tags are making 4, 5, 6 requests, each around 5 kilobytes. That adds up. It's exponential. Then you talk about other tags that are piggybacking and loading in additional tags, which again, those are making 2, 3 requests, and you're talking about 5, 10 kilobytes for each one of those. It adds up, and it adds up very quickly, and that's why we need to have a really firm grasp on what's going on and visibility into those different aspects. Perfect segue there, talking about the actual tag requests. So a tag request is just the number of time that tags need to make a network request. For an image pixel, this might be just one. It's just sending a static URL, just a counter up to a particular platform. For others, it might need to load in one JavaScript file, which then creates a request and loads in additional JavaScript files, which then creates more requests and actually executes and sends up the data to that particular platform. But when we talk about tag requests, we're talking about the total number of requests happening on the page. That would be across all tags, all platforms. Now, in addition, as I mentioned before, the resources in the browser, the resources, the bandwidth that's being used up, it's shared by all network requests, not just tags. It's not just tags, it's not just Google Analytics, it's not just DoubleClick that is using up those resources. It's also the content of your page, the styling of your page, the images on your page, all functionality there. So we need to keep that in mind, especially like Tyler had touched on, when it comes to prioritization of platforms, when it comes to prioritization of resources, and what needs to be loaded in and what needs to be loaded in when.
So one of the things that we want to talk about too that is a pretty hot talking point really that a lot of people just skip over, and that's how many tags can load at once? So if you think about, it wouldn't be insane to think that like probably 2,000-3,000 requests are made on a given page of these things coming in, which they're tiny requests. They happen in milliseconds and they all fly through, and nobody really knows what's going on as far as the number or how important they are. But how many can happen at the same time? So if we say these tags are running asynchronously and these requests are happening asynchronously, well, how many can they open? So per host name, these are your numbers on the left. What that means is, so when we talked about DNS lookups before, so say there's a Google Analytics tags, that the numbers on the left are how many they can open up per host name. So how many Google Analytics tags can be opened asynchronously concurrently. The number on the right is per browser, all host names. So even if we look at Chrome 32 for an example, I could have 6 Google Analytics tags loading in at the same time, but I can only have 4 more total on top of that anyways, because I can only have 10 tags loading in at the same time. For IE9, apparently it's 35, which is hilarious. I don't know that the processing was fast enough on that. For some reason, they backed it up down on the next 2 versions. But yeah, we're working up to set kind of web standards and how many we can pull in at a time. But essentially, what we're trying to do with these is judge where are the bulks that tags are bunching up. So what does this 10 connections really mean? How much is too much? You say, well, if it can only load 10 things at a time, how am I loading all these thousands? Well, some of them don't take long, some take longer, but we don't really want to clog up the pipes. And if we are clogging up the pipes, again, why? Is this tag important? Should it be there? Should it be moved? We need to reposition these larger tags so that it's kind of a transcending waterfall and that we're only using up some of these pipes ever so often? So here's a visual. It's literally a waterfall. If you look about halfway down the page, you see that really long green bar. This was pulled from Chrome, and on this particular website, you can see on my number of connections, you can see this waterfall as it's coming through. A lot of these little blue dots are just really quick, in and out, done, that connection is open. So if I can only have 10 max open, it doesn't really matter if there's 10 are done immediately and we move on to the next 10 and the next 10. But there does look like there's a problem child right in the middle, which is that big green bar. For the entire time that green bar is taking up, the gray would be the latency, and then the download would be that big green section. So that's how long it took for me to talk to the server, and I'm sending ping requests and trying to figure that out. And then I started the download, and how long is it going to take for me to get the download through? That entire time, if we say this is Chrome and we're on 10 connections, well, I only had 9. Now, all of those tags that are loading underneath it as they're coming through, I only had 9 other connections open during that time. And there might be some other things that are not visible that got executed during that time, but it took up that huge chunk. And then we move on to the next section of the waterfall and the next section. So the longer that you have tags loading, it's harder to load in multiple at a time. So these are nice visuals and understanding the number of tags loading and how it affects your website. So in the case, all of these blue blocks, let's pretend they're the exact same tag with the exact same download speed, just to make it simple enough to understand how this graphic works. In this first case, we put on the HTML, and then it's time to start loading these components in, these other things. Well, if we can load 2 tags at a time, you can see we do 2 components, and then those finished at the exact same time, and then 2 components, and that one kind of steps down. You can see the staircase that it's creating of the 2 stepping down. If we move to the infographic to the right, well, that one can do 4. So in whatever unit of measurement we're saying, we can say it takes a second for each blue section to execute. It took us 5 seconds in the first one. In the next one, now we're executing in units of 4. So we do 4 at a time. We step down. These are steeper steps now. Be careful stepping down. But this would only take 3 seconds. It went over 3 blue block sections, because we were doing them all concurrently. As we step up to more tags executing, now we're up to 8 in this bottom graphic. It only took us 2 seconds because we were able to execute them all at the same time. The concept's probably landing by now, but what does this mean? How does this affect my page? What should I be changing? How does this affect me? You should look for problem areas that are going on your page, or places where too many things are loading in at once that they shouldn't be. So this is where you look at the number of tags, the number of downloads, how many requests are being made at different parts, and are we clogging up some of our resources? Our internet resources, like I've said a few times, are being split amongst these blue blocks. So on the top left, If we had 2 megabits down and we were splitting that 2 megabits, there'd be a megabit per resource. And that's limited to the download coming from the actual server, but if we move over to the next one, the 4, splitting that 2 megabits, it would be half a megabit per. Down on the 8, it would be 0.25 megabits per. But we're splitting those connections, so we can only split this resource so many ways. So how do we optimize these different pieces?
This is just more of a graphic representation to show us exactly what Tyler was talking about. So as you can see, there is, again, a moderately strong correlation here between tag count and page size and those different page timing events. Tag count is not as strongly correlated as our overall tag size and the overall page size, but it is a factor, and it does matter, as we can see here by this model. So, and if we think about it logically, it makes sense. The overall, the more tags you have, the more requests you have, the larger the size that's going to be factoring in there as a result of tags. So what metrics really matter? Correlation is in the size of the page, the size of the tag requests, and then the total number of requests. These are the things that we need to optimize in order to minimize any potential performance impact as a result of tags on the site. And again, it underscores the need for optimal and lean tag architecture. Now, I don't want to throw latency away completely because it does matter in the sense of we need to know what to expect. If we have a tag that sometimes is only taking 50 milliseconds, but other times it's taking 600 milliseconds, that's a problem child on the website. We don't know, we can't prioritize and we can't optimize our overall tag architecture due to that thing loading erratically. One other extremely important point that I want to make here is, again, when it comes to piggybacking. So this is a visual of the hierarchy coming out of Tag Inspector. You can see there everything, moving from left to right. Everything in that first level is loading directly from the page. Second level is loading through or piggybacking off of whatever it's connected to. Some of these you can see are loading in a ton of other platforms. Double click, as you can see down there at the bottom, you're talking about loading in 15 to 20 different platforms. Some of those, again, loading in even more. So the effect of having that double click tag in that, as it's currently configured on this particular website, is not just loading in double click and the 2-3 different requests that are being made from double click, and maybe the 10-15 kilobytes that are associated with that double click request. In addition, it's everything that's loading through it, everything that's piggybacking off of it, because that is the portal through or the window through which all those other tags and those other pixels are loading in on the website. So we have to keep that in mind. This is why piggybacking and daisy chaining of tags matters so much, beyond simply security and not wanting, where's your user data going, but also when it comes to the performance of the website. So how do we optimize? We need to think about, as I talked about originally, thinking about the device type and the connection of users. What type of bandwidth are our users working with? How much CPU, how much power, how much processing do their devices have? We need to determine the page size that at maximum is going to allow our goals to be met. At least give ourselves a chance. At least give ourselves a chance when it comes to the total page size based upon that typical profile of our users. And then thinking about, after critical items like your content and images, how much is available for tags? Look at the actual content that really, really matters on your website and see how much of our overall budget does that take up, and then how much leeway do we have to load in additional tags, pixels. How much is budgeted, if any? And then we also want to think about opportunities for loading tags a little bit later in the overall page execution so as to remove the potential for user experience issues. As Tyler touched on with those different page timing events, once all that content and everything on the page is loaded in, we can pretty much have at it. You can load in a lot of different tags after that point and not affect user experience at all. Now, doing that, and this is just a visualization, I know we're quickly running out of time, but it breaks down when tags are loaded and how we can optimize. We can look at the page timing events, on average for a particular page, see what tags are loading where. We can move up our really critical platforms and things that are less apt to cause any sort of a performance issue, and we can move down anything that is heavier or more likely to cause any sorts of problems.
So quickly, just looking at this visually, you see in the blue you've got a 247, a 329, and a 458. Then right underneath it, barely in the orangish red, there is a 395. Those are very high up. Like I said, DOM Interactive is the earliest JavaScript we can run, and then so these are 4 double-click campaigns. It's possible those campaigns aren't running anymore. It's possible that they're loading in the same double-click library 4 different times, and that those aren't even campaigns yet. The JavaScript meant to run one campaign that all of them could leverage. It's about using these kind of resources to find these types of troublemakers that are early on. So when we're looking at these huge, that's literally a second of load time. If you were to take those down to 1, this particular site, if they got those down to 1 double-click tag, like 1 floodlight container or something, could literally get a second of time improvement just off of that change alone. So using stuff like this is you have immediate page impact performance. We can move on.
So last point I just want to quickly get to is the data considerations when it comes to tags. So not only moving things up and moving things down, prioritization of tags so as to minimize any sort of potential performance impact, but we also want to keep in mind prioritization of tags from a data collection standpoint. If we have a particular tag that is really important to the business, we're making a lot of decisions, doing a lot of analysis on data collected by that platform. We need those critical platforms to load higher in the execution order. As Tyler mentioned, there's a finite number of concurrent things that can be happening on a website. If we're executing non-important tags higher than our important ones, the priority for those are getting pushed down. So it's going to be later in that overall page load or later in that time that a user is on the page prior to those being able to execute. And if the browser never gets to those before a user leaves the page, we're not collecting any information. So we have gaps in analytics, we have gaps in our audience creation, whatever it may be for that particular platform. It's not working, and it's not working because of a configuration issue. Everything could be set up properly. You're loading it through the tag management system. All the settings and everything within your script are right, but you're having gaps in data collection because of performance issues caused by other tags on the page. We can see that here visually. We have start time, end time of all requests on a page, so we can see exactly how those things are loading. But we need to optimize. So quickly, just to run through a summary, and I know we're pretty much out of time, so I see a few questions here. We're going to follow up on them right afterwards. We'll send out answers to all those via email. But just to summarize, in terms of the performance of our website, tags do matter, but the metrics that we're looking at need to be adjusted a little bit. So we're looking at things overall when it comes to performance metrics with tags. We're looking at tag latency, which no real impact on the page performance itself. Overall page size, overall tag size, or how much size tags are adding to the overall size of the page, and then the request volume of all those different platforms.
So lots of information got thrown at you guys, and for some of you that may not have known some of the technical things, it may be way too much. So you're asking yourself, what do I take away from this, or how can I make an immediate impact on my website? One thing would be understanding your user base, because part of optimizing for tag structure is understanding your user base. Are they mostly on mobile? Are they mostly on desktop? Do they have faster connections? Do they tend to be the older crowd, so the older users tend to have less updated browsers? Is they younger, more updated browsers? Or are they older but also tend to have updated browsers? Understanding how on the biggest section of my user base, how many concurrent connections they have, what's the average connection speed, all of these different things are the arsenal that you can have as a business to then gain this information. And with the information that you can gather from the tools like Tag Inspector and the information you can gather on your user base, you then have all of the weapons to go in and combine that information and make smart decisions about what's going to improve your website, what is the monetary value for increasing page timing, and how can I get there.
Perfect. So I want to thank everyone again for joining today. Hopefully this has been useful, and hopefully, we're able to give you some things to think about and really look at on the website and when it comes to optimization of tags, especially as we head in here to getting closer to code freeze and getting into the holiday season. So let's optimize the tags, let's optimize the architecture, and as a result, optimize the performance so we can get more conversions and more revenue and sales and profit here at the end of the year. Thanks everyone for joining. Let us know if there are any follow-up questions. As mentioned, all the questions that you guys have submitted, we'll follow up on and get out to you. But thank you, and hopefully we will see you soon.